Can speech perception deficits cause phonological impairments? Developmental language disorders like dyslexia and DLD are characterized by poor performance on phonological tasks, which involve identifying, maintaining, or manipulating speech sounds. Perceptual deficit models attribute these problems to lower-level impairments in speech perception, and we want to ask, is this hypothesized causal relationship cognitively realistic? Our way of addressing the question is to experimentally disrupt speech perception in typical adults. We create a challenge at the perceptual level by introducing perceptual ambiguity and assess whether this directly affects performance on a typical phonological task, a verbal span task. We created continua varying between two capital letter sounds, such as B and D, and between a capital letter sound and a word sound, like B and we. We made 10 sounds at different points along each continuum by blending together the natural speech sounds in varying proportions. We pre-tested these stimuli in a 2 alternative forced choice identification task, and selected low ambiguity items with 99% probability of being identified as one endpoint of the continuum, and high ambiguity items with a lower identification probability. Experiment 1 was a simple auditory letter span. Participants heard lists consisting of either high or low ambiguity letter sounds, selected from either letter-letter or letter-word continua, and the list was 6 or 8 items long. We predicted that recall would be poorer for high ambiguity compared with low ambiguity lists. Experiment 2 aimed to replicate the findings of Experiment 1, but also to assess if the retroactive effects identified in the speech and noise literature would also hold true for phonological ambiguity. To address this question, we included 5 combinations of high and low ambiguity items, with high ambiguity occurring either at the beginning of the list, the end of the list, or mixed throughout. Here I'm showing the Levenshtein-Damerau distance, which reflects the difference between the target sequence and the actual sequence the participant produced, so a lower LD distance indicates better recall. And we can see that recall was better in the low ambiguity condition compared to the high ambiguity condition for both sequence lengths when the ambiguity was between 2 letter sounds. However, when the ambiguity was between a letter sound and a word, the degree of ambiguity made no difference to performance. In our second experiment, we successfully replicated the ambiguity cost for the letter-letter items. We then looked at retroactive effects. Here, our measure is accuracy for the first half of the list. If we compare the low-high condition with the low-low condition, we didn't find any differences in recall of that first half list between these conditions, so no retroactive effects. We also looked at prospective effects and found that recall of the second half of the list was similarly unaffected by ambiguity of the first half. To summarise, short-term recall can be disrupted by speech sound ambiguity, but this was specific to cases where the ambiguity was between 2 items that would both be appropriate responses in the short-term memory task, as is the case for the letter-letter blends, but not for the letter-word blends. So recall was only impaired if the task-relevant information in short-term memory was made more confusable. These results pose a problem for attributing poor performance in, for example, digit span tasks to impaired speech perception, because digit sounds are not very perceptually confusable. This suggests that impaired speech perception alone may not be able to account for the type of phonological impairments seen in developmental language disorders.